Okay, great. Good morning, everyone, and welcome welcome to the presentation on FC-3, which is Materials Protection, Accounting, and Control Technology. I'm Mike Rime, the Program Manager in the Office of Nuclear Energy. You can see the org chart there on the bottom left. There we go. I will be presenting on MPACT, which is a program within NE. And our main goal is to support U.S. Domestic advanced fuel cycles, specifically to help industry developers to effectively and economically address international and domestic materials control and accounting requirements. So, in a word, we are trying to safeguard U.S. fuel cycles. And we also want to enable the ability of industry to potentially export technology as needed. How do we plan to do this? We have two primary strategies or approaches. Really, the main thing we do is develop innovative technologies, analysis tools, and what we call integration methods. So we actually develop real-life tools that, like detectors, modeling, and approaches that demonstrate advanced MC&A technologies. We're looking to improve resolution and efficiency in detectors, or potentially synthesize data from multiple sources into one source that is more effective or provides more information than an isolated measurement. Additionally, we are trying to apply these tools in some cases to facilities or potential fuel cycles that are very challenging to do traditional safeguards measurements or techniques, such as counting spent fuel rods or canisters, things like that. So we're trying to take on the challenging and difficult problem associated with advanced fuel cycles. So the second way that our program pursues our main goal is to coordinate and engage with industry and stakeholders, including governments, early in the technology development process. So we meet and discuss safeguards with groups like NEI, NRC, NNSA, and usually indirectly with IAEA via NNSA, because that's that is their program and their mission. But we've performed technical assessments in support of fuel cycles and approaches for some of these organizations, and we've helped develop guidelines as well. So we really rely heavily on the national lab infrastructure and expertise, as do many of the government agencies that work in the safeguards area. This slide shows an overview of the areas that the Office of Nuclear Energy focuses on, and it should say FY20, so this is current. But really, the Office of Nuclear Energy conducts activities across the entire fuel cycle. But MPACT, and specifically for this call and for the MPACT program, we are very much interested in enrichment and fuel fabrication, especially fuel fabrication for advanced reactors, as well as recycling. So whether that's aqueous, pyro processing, or potentially novel recycling methods. And again, very much focused on advanced fuel cycles, and specifically advanced reactor fuel recycling. Now that's a very lofty term because there's a lot of uncertainty, or there's a lot of diversity in the types of reactors and the types of fuel that could be part of that. But at a high level, that is what we're interested in. So I'll walk through some of the MPACT R&D challenges, the things that we think are important to address. And again, it will give you background information for the scope of what we're looking for in this call. So advanced fuel cycles, including fuel fabrication, and as I mentioned, recycling, presents a number of safeguards challenges that aren't always easily addressed by existing technology and approaches. You have things like very high heat, high radiation environments, potentially moving sources in a reprocessing facility. You also have reactor types that include different approaches for online processing or adding materials. Well, in addition, you also have new products and waste streams. So you have things like HALEU fuel fabrication. Many of the advanced reactors that are being considered use HALEU fuel. And also, there's a lot of questions about the exact type of waste streams that will be utilized in different advanced reactors. So all of these things provide a little bit of uncertainty, which makes it challenging to develop technology in the sense that there are a lot of unknowns. However, it's kind of exciting because it allows us to solicit proposals that are really novel and innovative and can potentially address some of these issues. Finally, I wanted to touch on the second bullet, another main challenge in R&D in this area. In a lot of cases, it's really going to require a combination of approaches to do safeguards on advanced fuel cycles. So it's not going to be a simple counting or a simple measurement. Oftentimes, it's going to be gathering data from multiple measurements or a detector that can measure multiple things, like neutron gamma, or you can do sampling with there are visual techniques for sampling molten salt, for example. But overall, we're looking for interesting and novel detectors and approaches, things that can improve accuracy and precision of accounting measurements. These are somewhat generic metrics, but like I said, it's a pretty uncertain area. So we're looking for novel ideas here. Additionally, of course, you can expand the scope of what can be detected, especially when you're talking about measuring actinides in liquid-fueled reactors or liquid-fueled recycling facilities, which are, like I said, there's kind of a Venn diagram where those two things can start to look very similar depending on what the reactor developers choose to do. And also combining indicators in a novel way to generate new data. This is my final slide, and I think I'm actually pretty good on time here. But this is the full language of the call. And just as a quick summary, we seek to develop technologies and data integration to enable fuel cycle management and safeguards. We're looking to enable integration of safeguards and security features into the design and operation of nuclear fuel cycles. We're looking to fill technology gaps for emerging fuel cycles. And we're very interested in things like advanced fuel fabrication, used nuclear fuel recycling, hold up in bulk nuclear facilities, long and short-term storage, and waste streams from these advanced reactors and advanced fuel cycle facilities. Yeah, so that's a pretty good way to wrap it up, actually. And I do want to emphasize, if it wasn't clear in the presentation, our focus is very much on fuel cycles. We have, for a number of programmatic reasons, we have shifted away from safeguards for advanced reactors specifically. So we are more interested in front end and back end of the fuel cycle for advanced reactors. Anyway, I will pause there and answer any questions.
Okay, thanks for the presentation, Mike. Please submit your questions in the question box on the GoToWebinar application. We'll hold Mike here, and I believe we may have Mike Brown, who is the TPOC. No, so we just have Mike Rhyme here to answer questions. Please submit them if you have them. Thank you. Okay, Mike, we're ready with some questions. Does nuclear criticality safety play a part?
That's a good question. I haven't traditionally included that in our scope in the sense that it's a specialized area. And oftentimes, I think there's a specific call for proposals that is uh, in that area. Obviously, criticality is extremely related to safeguards. So if the prospective PI thinks that there's enough overlap between their criticality research and the ability to measure actinides in either directly or indirectly in a fuel fabrication facility or a pyroprocessing or aqueous or novel recycling facility, then I think it definitely could it definitely could overlap and it could be applicable.
Could you give a few examples of which materials are especially interesting to you?
So I mean, primarily, as we're primarily the main item of interest is S&M. The either NRC or IAEA guidelines for S&M is really what drives the program. Of course, there are potentially indirect ways to measure that, but considering this is a domestic program, we often have plenty of access and plenty of information at hand, potentially in these sorts of facilities. Like, it's not in a black box like sometimes the international community or IAEA has to deal with. But really, we're talking about, uranium and plutonium primarily.
Is this scope mainly focused on computational or experimental work?
For the most part, I would say experimental. We have funded some modeling, but I personally am a little, because we have kind of a limited number of projects per year or in total, really. I personally kind of trend towards trying to fund experimental work, but certainly I believe many of our proposals have had, if there's 2 or 3 phases, one of the phases is often modeling in order to set up the problem, and then some experimental work to validate or to strengthen what was done in the model.
Does novel detector applications form a part of this scope?
I mean, I want to say yes to that. It's sort of to be fair, I've been giving some open-ended answers, but that's a pretty open-ended question. But I would say in general, yes. And I am very interested in seeing novel detector design when it comes to having a very specific application for safeguard.
Will materials like high entropy alloys be of any interest in this category?
I'm actually not familiar with that subject. If either if that topic can help in some way when it comes to making nuclear material accountancy measurements, then I would say yes. But I'm not very familiar with that.
Mike, could you move back to the 3rd and 4th slide again for a few more seconds on each of those?
Yes, hold on. Sorry, bear with me. So this is the 3rd slide, correct?
Correct.
Okay.
Give us about 10 seconds on each slide.
Yeah, no problem.
All right, as you shift to the 4th slide, Mike, I'm going to ask you another question.
Okay.
Will materials control and accountancy for repositories be captured by this scope?
That's a good question. Um, that's actually a gray area. I would say no. Um, I did mention long-term storage on a slide, so that's a fair question. I think I'm more interested in uh, characterizing and measuring unique waste forms that may be associated with uh, recycling fuel from advanced reactors. And ultimately, that may result in something that goes in a repository. But I think that's a little bit, it's sort of like the further along you get to the right, I think there's more uncertainty. So I think there's plenty of challenges and plenty of uncertainty when it comes to characterizing and measuring advanced reactor waste forms without going so far as to start getting into repository related research.
Okay, Mike, those are the questions we have. Thank you all for attending the AMPAC presentation. We will be picking back up after a lunch break at 1 p.m. Eastern Time for the cybersecurity and integrated energy systems presentation. So please join us then. Thank you.
Okay, thanks so much.